Welcome to the Turf Zone podcast. This episode features the article Advancing Precision Weed Management in Turfgrass Systems with Machine Vision Guided Targeted Spraying. Written by Brooke Heikkila, Graduate Research Assistant. Navdeep Godara, Assistant Professor of Turfgrass and Forage Weed Science, Department of Crop and Soil Sciences, North Carolina State University. And Pawel Petelewicz, Assistant Professor of Turfgrass Weed Science, University of Florida, Institute of Food and Agricultural Sciences, Agronomy Department. Turfgrass managers are facing increasing weed challenges due to evolving regulatory framework and growing incidence of herbicide-resistant weeds. The release of the first turfgrass-specific commercial machine vision-guided sprayer, ALBA Ecorobotics Inc., enables automated and localized herbicide applications in turf. Although often referred to as spot spraying in marketing materials, targeted spraying is a more accurate description as it distinguishes this system from manual spot treatments and other existing precision weed management approaches. Such targeted application systems have already been successfully deployed in other crops using platforms such as the John Deere See and Spray, Agritech America WEEDIT, Verdant Robotics Sharpshooter, Ecorobotics ARA. Using See and Spray technology, comparable weed control was observed between the broadcast and targeted spraying methods, but the targeted spraying reduced the treated acreage by up to 2/3. In turfgrass, this technology not only offers significant herbicide savings, but also opens the door for practitioners to combat herbicide-resistant weeds by incorporating alternative chemistries, including non-selective herbicides or herbicide tank mixtures combining multiple modes of action which are not typically feasible in broadcast applications. Overall, spot spraying is not a new concept, as many turfgrass managers already employ it to control weed escapes following broadcast herbicide applications or where selective chemistries are not an option. Manual spot spraying involves individuals walking the golf course or other turfgrass areas with a sprayer loaded with herbicide to make localized applications directly to weeds. Traditional spot spraying is labor-intensive, time-consuming, and requires applicators to accurately identify weeds, necessitating additional training and expertise. It ultimately increases application cost and is also prone to human error, often resulting in over-application and missed weeds. However, targeted spraying systems such as ALBA utilize artificial intelligence combined with machine vision to detect problematic weeds within turfgrass canopy in real time to apply herbicides only to those small areas where individual weeds are present. ALBA is a tractor pull-behind unit that can operate at speeds up to 4.5 miles per hour and uses an enclosure to block ambient light and to create consistent lighting conditions to continuously scan the turfgrass canopy with its cameras to detect weeds. When a weed is spotted, an individual nozzle 1 out of 108 activates to directly target the weed with a 1.2 times 1.2 inch spray resolution per nozzle. As targeted application systems continue to advance and competing platforms emerge, it is critical to understand how to effectively integrate and leverage these sprayers within turfgrass weed management programs. Several preliminary field experiments using ALBA and its ARA-based predecessor research platform were conducted by the NC State Turfgrass Weed Science Program and the UF/IFAS Turfgrass Weed Science Program to understand the applications of this technology. Preliminary studies showed that machine vision-guided targeted spraying substantially reduces herbicide usage and treated acreage while maintaining weed control efficacy, offering both economic and environmental benefits while targeting wide variety of problematic weeds with high accuracy. Reduction in herbicide volume used in a study focused on controlling false green killinga in Bermuda grass fairways. Machine vision-guided targeted spraying with ALBA reduced herbicide spray volume by 77% compared to broadcast treatments. False green killinga cover was 17% at the experimental sites during study initiation, triggering significant savings due to the weed-specific, localized targeted treatments compared to broadcast herbicide applications. Broadcast applications of standard killinga control products typically cost around $190 to $240 per acre, but targeted treatment can lower the cost by more than $145 per acre even when dealing with moderate level of weed infestation till to 15% weed cover. Similarly, in another ongoing study, when annual bluegrass weed cover was 10% in Bermuda grass fairways, targeted applications achieved a 66% reduction in herbicide spray volume compared to conventional broadcast treatments. Sulfonylurea herbicides for post-emergence control of annual bluegrass cost around $140 to $185 per acre, and targeted spraying can reduce the cost by at least $92 per acre when weed cover is 10% or less. Practitioners can expect greater savings at turfgrass sites with lower weed infestations, which are typical of intensively managed surfaces and when applying expensive herbicides such as Pocure or organic herbicides during winter dormancy of warm-season turfgrasses. Targeted application system was also evaluated for control of broadleaf weeds, Dallas grass, smooth crabgrass, and tropical signal grass in studies conducted independently or in collaboration between Mississippi State University, NCSU, Virginia Tech, and UFIFAS, and observed a 53% to 95% reduction in spray volume. In all the aforementioned cases, weed control levels achieved with targeted spraying were no different from broadcast applications. Thus, these studies demonstrate that, across various problematic weed species, this novel application system can substantially reduce the herbicide volume required, lowering costs without compromising weed control efficacy. Lower treated acreage. During broadcast herbicide applications, substantial areas without weeds are often treated unnecessarily. Targeted applications can reduce the treated acreage, enabling practitioners to use herbicides such as MSMA, which are currently restricted to spot treatments on less than 25% of the total golf course acreage per year. Targeted spraying systems are particularly useful for herbicides with limited or no residual activity, as it allows localized treatments to weed instead of broadcast applications to turfgrass. Targeted spraying for false green killinga control, 17% weed cover in Bermuda grass fairways resulted in 85% reduction in treated acreage compared to broadcast spraying. In a similar study, an 80% reduction in treated acreage was found when only treating annual bluegrass in dormant Bermuda grass at 10% weed cover. A study conducted by UF/IFAS Turfgrass Weed Science Program using circular, non-overlapping targets of varying patch sizes, 4 to 10 centimeters diameter, to simulate random different weed densities and dispersions within the 1 to 20%, 21 to 40%, and 41 to 60% coverage, indicated total spray deposition of approximately 40%, 64%, and 74%, respectively. This corresponded to estimated herbicide savings of 60%, 36%, and 26%. Spray deposition increased with rising weed pressure, while the non-sprayed area, directly reflecting herbicide savings, declined accordingly. These results confirm that variation in herbicide savings with targeted applications is driven primarily by weed density, with dispersion playing a secondary role, exerting stronger effects at low weed densities but negligible influence at higher densities. The reduction in treated acreage can potentially diminish the environmental impact of herbicides by minimizing overall pesticide load released into the environment, limiting off-target movement, reducing the risk of groundwater contamination, and lowering the risk of human exposure associated with pesticide applications. Targeted approaches permit treatment to a limited portion of turf, enabling the effective use of chemistries with area use limitations. Effective reduction in area treated with targeted spraying will become increasingly important as new regulations come into effect, particularly in the context of upcoming Endangered Species Act imposed changes. Therefore, research projects funded by the Turfgrass Council of North Carolina will focus on investigating the agronomic and environmental benefits of targeted application systems for managing problematic weed species. Alternative herbicide options for resistance management, targeted spraying also enables selectivity at the sprayer level rather than relying only on selectivity of the herbicide used. This potentially allows turf managers to use non-selective herbicides that were previously not an option for broadcast treatment due to severe injury to actively growing turf grasses. Broad-spectrum herbicides like glyphosate, glufosinate, or flumioxazin are highly effective against a wide variety of weeds, but practitioners often wait for turfgrass to go dormant before spraying non-selective herbicides, while in some geographies, such as Florida, achieving full dormancy is not even possible. However, with this new technology, practitioners will have the option to incorporate non-selective herbicides year-round with minimal collateral damage to turfgrass. Glyphosate Roundup Pro concentrate applied via broadcast application at 12 fluid ounces per acre rate reduced Bermuda grass green cover significantly, but targeted spraying had similar level of green cover as non-treated plots, as documented in our recent study. Likewise, glufosinate applied at 41 fluid ounces per acre, as Phenali X LT&O reduced Bermuda grass cover drastically after broadcast application but had minimal effect on turfgrass. After targeted spraying technology also allows use of novel admixtures that are not currently being used during regular turfgrass maintenance. Rotating or tank mixing herbicide from different modes of action are crucial for sustainable turfgrass management, as selection pressure for herbicide resistance continues to increase. For instance, practitioners can use tank mixtures of herbicides like pyridate plus sulfentrazone or bentazone plus halosulfuron plus sulfentrazone for targeted spraying without compromising efficacy on false green killinga. These novel admixtures contain multiple modes of action in a single application that could reduce selection pressure and combat herbicide-resistant killinga. Similar admixtures should be explored for the management of other herbicide-resistant or difficult-to-control weeds. Limitations. Like with any new technologies, there are limitations to consider when adopting a machine vision-guided sprayer. Currently, only one commercial unit, ALB by EcoRobotics Inc., is available, providing managers with a single option for this turfgrass-specific targeted spraying technology. Additional machine vision guided sprayers need to be developed specifically for turfgrass systems, as interest in these technologies among turfgrass managers continues to grow and the needs across different turfgrass industry segments will vary. The cost of the equipment and the annual model subscription will be a major barrier for many turfgrass managers. Offering incentives, such as reduced subscription fees for the first few years, could help increase adoption of this technology. Alternatively, with ALBA being an example of a high-end solution maximizing performance and system sophistication, other developers may consider trade-offs to reduce equipment production and maintenance costs to improve accessibility. Although ALBA seems to demonstrate high detection accuracy on key problematic weeds, further research is needed to understand its year-round performance, considering changes in visual characteristics of weeds and turfgrass across growth stages and under varying environmental contexts. In our preliminary work, a few false positives occasionally led to herbicide applications to weed-free turfgrass. Also, we observed that in situations where weed presence, particularly grassy weeds, in the camera's path exceeded that of turfgrass, the detection system became confused, effectively reversing target and background and treating turfgrass instead of the weed. However, developers are actively addressing these shortcomings and performance of targeted application systems by continuing to improve imagery databases, training, and validation across diverse geographical regions and management contexts. There is no doubt that machine vision-guided sprayers will have a transformative impact on the turfgrass industry. However, extension efforts will be critical for adoption. Also, as this technology is still novel for turfgrass systems, ongoing research and development is critical to improve performance, reliability, and to meet industry needs. Among others, further research is needed to evaluate performance under varying travel speeds, expand applications to targeted residual treatments, and refine application thresholds to maximize herbicide savings. Authors acknowledge the Turfgrass Council of North Carolina for sponsoring ongoing research projects focused on leveraging targeted application devices for weed management in NC turfgrass systems. The authors also thank EcoRobotics Inc. for providing a commercial unit for evaluation. You have been listening to the Turf Zone podcast. Follow the Turf Zone on X, Facebook, and LinkedIn for all things turfgrass, featuring podcasts, magazines, events, and more. Visit www.theturfzone.com for more.